Okay, when asked to simplify the reference triangle, you want to start with your innermost trig function, which is probably going to be an inverse trig function. And the inverse trig function kind of tells you what your reference triangle is going to look like. And then regular trig is going to tell you to pull from that reference triangle that you created. So we got to know SOHCAHTOA for this. So cosecant is the inverse of sine, right? And then sine is opposite over hypotenuse. So if sine is opposite over hypotenuse and cosecant is the inverse of that, then cosecant must equal hypotenuse over opposite. Just the flipped version of sine, right? So what that tells us is that the corresponding, that our numbers correspond like this. So that x corresponds to the hypotenuse, and then that 4 corresponds to the opposite side being the opposite side of theta. And then also when we're drawing a reference triangle, theta always goes in the bottom left quadrant. Yeah. Okay, so, and then, it's also a right angle. So now we've got this, and whenever we have a right triangle with 2 sides filled in and we want to figure out what the third side is, we use the Pythagorean theorem, right? A squared plus b squared equals c squared. So our hypotenuse is x, so that becomes x squared. Our b is 4, so that just becomes 4 squared. And then this is going to be our a side. So a squared equals x squared minus 16, because 4 squared is 16, and then we subtract 16 from both sides to isolate the a and get it by itself. So a ends up being x squared minus 16. Technically plus or minus, but that doesn't matter for this problem. Okay, so now we've got our completed reference triangle, and so now we can move on to the secant part of it. Secant is the inverse of cosine, and cosine is adjacent over hypotenuse. So if cosine is adjacent over hypotenuse, then secant must be hypotenuse over adjacent, right? Because it's just the flip, same thing, or similar thing with cosecant, right? So then that is going to be secant equals x divided by square root x squared minus 16. And then if you want to get rid of that radical in the denominator, we can multiply by the square root in question, and then that will give us x square root x squared minus 16 divided by x squared minus 16. And you could write this as x plus 4 times x minus 4. I think you're all right to leave it like this, though. So this is going to be your answer. Okay, so now for this one, so we're going to find all theta on the interval 0 to 2 pi that satisfies sine theta minus 2 sine squared theta equals 0. So really you just start out with factoring out a sine, right? So this can be, sine theta times 1 minus 2 sine theta. You just factor 1 out, equals 0. So now you've got 2 terms that could potentially equal 0, and if either one of them equals 0, then this whole left side equals 0. So anything that makes either one of these 2 terms equal 0 is going to be a 0. So what makes the yellow term sine theta, what makes that equal 0? And this is a unit circle question, right? So if you remember your unit circle, it's our quadrant 1 angles are 0, pi over 6, pi over 4, pi over 3, and pi over 2, and then it follows the coordinate pair cosine sine. So cosine is kind of like your x value, and sine is kind of like your y value. So 0 makes this equal to 0, right? Because the sine value of our 0 angle is 0, and then also pi, right? Because out here at pi, it also equals 0. So those are the zeros that we're going to get from that term. As for the blue term, 1 minus sine theta equals 0. So we can add 2 sine theta to both sides, divide by 2, 1/2 equals sine theta. So, theta equals sine inverse of 1/2. You can think of it like you're taking the sine inverse of both sides. And this is saying, okay, what pi values on the unit circle give me a sine value of 1/2? And that will be pi over 6, because the ordered pair of pi over 6 is root 3 over 2 comma 1/2. And so that has a sine value of 1/2, so we include it. And then, so that's going to be there. And then also our quadrant 2 rendition of pi over 6, which will be 5 pi over 6, also has a sine value of 1/2. So you would have 4 answers to this question: 0, pi, pi over 6, and 5 pi over 6. For this one, we're talking about factoring trinomials and wholes in graphs. So however you know how to factor trinomials is acceptable. It's definitely a skill that you will use not only on quiz 0, but definitely in the rest of the course as well. So when we factor it, we get this, and then these x minus 1s cancel out. But when you get two terms that cancel out, they never technically go away. They just create a hole at the 0 of the term. So wherever x minus 1 equals 0, you have a hole there, because if you didn't get rid of them, right, it'd be 0 over 0, which is indeterminate. So at x equals 1, we have a hole, because that's what makes our canceled terms equal to 0. So if we were graphing that, it would look something like this, as opposed to the graph of g of x, which is, where's the purple? The graph of g of x would look something like this. So if you were asked to describe the differences, you would say they're like the same exact graph, except f of x has a hole at x equals 1. Okay, now for odd, even, neither. So symmetry is if f of negative x equals f of x even, if f of negative x equals negative f of x odd. And all that really means is, right, like y equals x squared, right? The most basic parabola you can think of is the quintessential example of an even symmetry, and then y equals x cubed is like the quintessential example of odd symmetry. So if you reflect y equals x squared across the y-axis, it looks like the same exact graph. If you reflect y equals x cubed through the origin, it looks like the same exact graph. So that's just to kind of get a conceptual understanding of what's going on here. Algebraically, all we really need to be able to do is this. So what we do here is we literally just we take our function, right? We take everywhere we see an x and we plug in negative x. And so this negative x stays. This just becomes 2x, right, because the absolute value of negative x is x. And then down here, this also just becomes x fourth, or x to the fourth, because any negative number to an even power is always a positive number, right? So then this is what we get for our g of negative x. And now we can say, is this g of x? No, it's definitely not g of x. Is it g of x with a negative number hanging out front? Yes, it totally is. And that's all negative f of x is. So like, if the function you get when you plug in negative x is just the same exact function but with a negative sign chilling out front, then you have odd symmetry. So we would say this has odd symmetry. Okay, now for this marathon of a question. So draw y equals x squared, sure. Label the vertex, sure. label the points 1, 1, and negative 1, 1. Sure. So now we got to complete the square of this. And you complete the square by going, well, first you set the whole thing equal to 0. Then you move, or we set it equal to 0. Then you get rid of your constant term by moving it to the other side. So we'll add negative 7, we'll add 7 to both sides to get the negative 7 to cancel out on the left. Then you make sure you have an a value, or the coefficient of your x squared term, equal to 1. So in order to get that, we have to factor out a negative 3. So that becomes x squared minus 4x equals negative 7 thirds. And then now we can complete the square on this. So completing the square just involves adding b halves squared to both sides. B being the coefficient of your x term. So the coefficient of our x term is negative 4. Divide that by 2, you get negative 2. Square negative 2, and you get plus 4. So we have to add 4 to both sides. And negative 7 thirds plus 4 is, I believe, positive 5 thirds. So we get a positive 5 thirds over here. And then this is still negative 3 times just this whole entire thing. So, but now we can factor this. And when we factor it, we should get a perfect square. And that should be negative 2 and negative 2. Yeah, negative 2x, negative 2x. Negative 3, so that's going to be negative 3 times x minus 2 squared equals 5 thirds. So we're almost done. So now we can just reintegrate that negative 3. So we get negative 3 times x minus 2 squared equals negative 5. And then we can say negative 3 x minus 2 squared plus 5 equals 0. So now that it's back set equal to 0, we can just say f of x equals negative 3 times x minus 2 squared plus 5. So now that we've completed the square, we can say, okay, now we can graph this because it's this same function, but it is flipped. It has a stretch. It's stretched by a factor of 3. It is shifted 2 to the right, and it is shifted 5 up. So that happens. So then the vertex would be 2 to the right, 5 up here. It would be flipped and it would be stretched by a factor of 3. So notice how like this goes right out 1, up 1, and same thing on the other side. So instead of going out 1, up 1, we would go out 1, down 3. So then our point would be here. And then same thing on the other side. So these would be points. So then this would be, all right, so if we're at 2, 5, this would be 3, 2, yeah. And then this would be 1, 2. And then our vertex would be at 2, 5. So this is the vertex, and then these are the two corresponding points. So that's what you would get for that one. All right, now for domain ranges and symmetries. So the domain is just the acceptable x values, which means x values that you can plug in and get a real answer. So like, just think of it like, what can't you plug into the square root? You can't plug negatives into the square root, right? You can plug 0 into the square root, right? Square root of 0 is 0. You can plug positive numbers into the square root. That's totally fine. But negative numbers, you can't. So whatever makes the inside of this not negative is totally chill. So 1 minus x, right, we have to be greater than or equal to 0. That's saying we're either 0 or some positive number. So we can just do some very simple algebra. 1 has to be greater than or equal to x, or in other words, x has to be less than or equal to 1. So we say that the domain is from negative infinity up to 1, and then we have the closed bracket on 1 since we can be equal to 1. Okay, and then also you always have the open bracket, or sorry, the open parenthesis on negative infinity and infinity. Okay, now for the range. Range is just like what possible values can a square root give you. So like you take the square root of something, can it give you a positive number? Yeah. Can it give you 0? Yeah. Can it give you a negative number? Taking the square root of something will never give you a negative number. So then we say it can give us 0, so we put a closed bound on 0, and then we go all the way up to infinity. So the range, it will be 0 to infinity. For inverse functions, you just swap x and y and then solve for y. So we would square both sides, right? So x squared equals 1 minus y. We could do some algebra and say, okay, y equals 1 minus x squared. And then we would just say, what does this function look like? Well, this is a flipped parabola. Kind of think of it in terms of like the translation, right, from here. The negative sign means we're flipped, and then the +1 just means we're shifted 1 up. So we're essentially just this parabola, but we're flipped and we're moved up 1. So what is the domain of a parabola? Well, a parabola is a polynomial. Polynomials have domains of all real numbers, which is negative infinity to positive infinity, but they have ranges of 0 to infinity. So, but since this is a flipped parabola, we go all the way to negative infinity, and then since we're shifted 1 up, our end bound is at positive 1. And it's an inclusive bound, right? We use a closed bracket because that's where our vertex is, right? We can definitely be equal to 1, which we are at the point 0 to 1. Okay, so now f of x equals 1 divided by 4x, simplify that expression. So this is the difference quotient. This is actually relevant, and you'll be doing it a lot over the next month. So the first thing I like to do is I like to write down what is f of x plus h. And that is 1 divided by 4 times x plus h. So then we can simplify this, say, okay, this is 4x plus 1 over 4x plus 4h, right? So then we can substitute this into the equation. We can say, okay, 1 divided by 4x plus 4h minus 1 divided by 4x, all divided by h. So in order to simplify this further, we need a single fraction in the numerator. So the way we do that is we multiply each fraction by the denominator of the other fraction. So we multiply 1 divided by 4x plus 4h by 4x over 4x, and then we multiply 1 divided by 4x by 4x plus 4h divided by 4x plus 4h. So when we do that, we get one whole fraction with a denominator of 4x all times 4x plus 4h, and then this becomes 4x plus 4h. So now we can simplify this, still all over h. So then we can simplify this a little bit, right? Distribute that negative sign to both of the terms. Always be careful with that. That's one place where you might get tripped up, is if you distribute your negative incorrectly, you could get the wrong answer. And then now we just need to cancel our terms. So this positive 4x cancels with this negative 4x. This 4 cancels with this 4, and this h cancels with this h. So we are left with negative 1 divided by x times 4x plus 4h.